Welcome to the deep dive. In a world, well, let's face it, a world grappling with rising water scarcity and also the huge energy demands tied to treating that water, efficiency isn't just a nice idea anymore. It's becoming absolutely essential. We're really talking about a pretty critical shift towards smarter, more sustainable water use in our buildings. Today, we're taking a deep dive into the latest version of the Green Building Standards, specifically LEE Building Design and Construction V5 for new construction. At our focus, it's on a really crucial mandatory requirement, water efficiency prerequisite 2, that's WEp2, minimum water efficiency. We've got some great sources here, and our mission today is to really unpack what this requirement actually means, how projects can, meet it, and importantly, why it makes such a difference, not just for the building itself, but, well, for the planet. And hey, if you find these kinds of deep dives interesting, make sure you hit that subscribe button. It really helps you stay connected to this world, and you'll hear more about how we can all build a more sustainable future, one smart building at a time.
Absolutely. And what's really fascinating here, I think, is how LED V5 connects the dots. It isn't just about cutting down on how much water you use. It's fundamentally linked to lowering energy consumption and therefore carbon emissions.
Right, because getting water to us and treating it takes a ton of energy.
Exactly. Treating it, pumping it, distributing it, it's incredibly energy intensive. Think about the whole journey water takes to get to your tap, get heated, and then the wastewater treatment afterwards. So yeah, by focusing on water efficiency right there in the building, you're hitting multiple environmental targets all at once. This prerequisite, WEP2, it really pushes for an efficiency-first mindset, recognizing that ripple effect.
Okay, so it's mandatory. No getting around it if you want LED certification. And projects have to meet this. So can you walk us through the main areas a project needs to address to comply? And maybe what stands out to you as, the most important takeaway for someone listening? Or maybe the most challenging part for teams?
Sure. Yeah, it's mandatory. That's the key thing. The prerequisite sets minimum efficiency standards across three main areas. You've got your indoor plumbing fixtures, the taps, toilets, showers. Then you've got various types of equipment within the building. And finally, outdoor irrigation, so landscaping. Each of these areas has sort of pathways for compliance. It allows for some flexibility, which is good, but the end goal is always significant savings. And maybe the most surprising thing for teams, just how many hidden water users there are.
Right.
It goes way beyond just the faucets.
Okay, yeah, let's unpack that. Starting with the indoor plumbing seems logical. That's something we all interact with daily. It feels like the most obvious place to save water, maybe. But what does LD actually require there?
Right. So for all the indoor fixtures and fittings, projects generally have two ways to comply. The first one is called the prescriptive path. It's pretty straightforward. It basically sets maximum flush rates for toilets and urinals and maximum flow rates for faucets and shower heads. You just can't exceed these numbers.
Specific numbers, then.
Yeah, specific numbers. For example, toilets, and this includes the dual flush ones, they have to be 1.28 gallons per flush or less. That's about 4.8 liters. Urinals are even stricter, only 0.50 gallons per flush, so 1.9 liters.
Half a gallon, wow.
Yeah. And the real insight here isn't just the numbers themselves, but the collective impact. Hitting these targets can cut a building's indoor water use by like 30 to 50% compared to older, less efficient buildings. That directly helps with regional water stress and, crucially, lowers the energy needed to heat all that water. Big savings there, too.
So specific numbers for pretty much everything. Can you give us a few more examples? Like, what about the faucet in a public restroom versus my kitchen sink?
Exactly. They cover quite a range. Public lavatory faucets, think airports. Malls are capped low at 0.50 gallons per minute. That's 1.9 liters per minute. The idea is they're for a quick hand wash.
Yeah.
Private lavatory faucets, maybe in an office or hotel room, they allow a bit more flow, 1.5 gallons per minute or 5.7 liters, still way less than older faucets. Kitchen faucets get a little more, 1.8 GPM, that's 6.8 pound EPM, because you might be filling pots or washing vegetables. And shower heads, which are, a big water user, are limited to 2.0 gallons per minute or 7.6 pound EPM. And LED strongly recommends using WaterSense labeled fixtures. The EPA certifies these so you know they meet or beat these standards, makes it easier for the project team, often cheaper too.
That seems pretty clear for new buildings, just specify the right stuff. But what if it's not that simple, like maybe a renovation project where changing every pipe isn't feasible? Or what if a team has a really clever water recycling system or something? Is there like another way besides hitting every single fixture number?
Yes, absolutely. And that's where The second option, the performance path, comes in. It offers that crucial flexibility. Instead of meeting every single prescriptive limit for each fixture, projects can choose this path if they can demonstrate an overall reduction in their total indoor water use. They need to show at least a 20% reduction compared to a calculated baseline consumption. That baseline represents sort of a standard building.
Ah, okay, so it looks at the whole picture.
Exactly. It allows for more innovative solutions. Maybe you have one process that uses a bit more water, but you make up for it with super efficient restrooms elsewhere. It's really useful for complex projects or, like you said, renovations where hitting every single prescriptive target might be impractical or overly expensive.
Okay, that makes sense. So that covers the taps and toilets. But you mentioned equipment. That sounds like where things get really interesting, maybe less obvious. Where else are buildings using significant amounts of water? And how does LE address those? Thinking things like, I don't know, commercial kitchens, laundries, maybe even HVAC.
That's a great question because this section, yeah, it gets into those less visible but often very significant water users. It's pretty comprehensive. We can break it down a bit. First, you have what you might call common appliances. So things like residential and commercial clothes washers, dishwashers, they all need to be Energy Star rated or equivalent.
Right, so that covers energy and water.
Correct. They're designed to be efficient on both fronts. Then ice machines, they can use a surprising amount of water, especially older models. So they also need to be Energy Star, and this is key. They must use air-cooled or closed-loop cooling systems. No more of that once-through water cooling for ice makers.
Ah, the ones that just constantly run water down the drain.
Exactly. Huge waste. Even smaller things like the pre-rinse spray valves in commercial kitchen sinks, they have a limit too. 1.3 gallons per minute or 4.9 LPM. Seems small, but in a busy kitchen, it adds up fast.
I can see that. Okay, what about bigger stuff like those massive dishwashers in cafeterias or industrial processes?
Yeah, so then you get into specialized kitchen and process equipment. For those big commercial kitchen machines, LED5 sets specific water consumption limits per cycle or per hour. For example, a multi-tank conveyor dishwasher can't use more than 0.9 gallons per rack. Flight-type machines, the really huge ones, might have a limit like 180 gallons per hour. These standards target those really high-volume water users in commercial settings. And then maybe the biggest impact area is major building systems and processes. This is crucial. LED5 completely prohibits once-through cooling using potable water.
Just bans it outright.
Bans it, using fresh, clean drinking water just once for cooling and then dumping it. Not allowed. This is a massive change, preventing potentially billions of gallons of waste in industrial and large commercial applications. And then cooling tower is essential for many large buildings' climate control. They have strict rules too.
Like what?
They need makeup water meters, so you know exactly how much water they're using. They need conductivity controllers. These help manage the water quality inside the tower, allowing you to use the water longer before needing to drain and refill, saving water. They also need high-efficiency drift eliminators, rated at 0.001% or 0.002% drift. That stopped water droplets literally drifting away on the air.
Tiny droplets, but adds up over time, I guess.
Absolutely. And things like discharge temperature tempering or heat recovery are encouraged or required. Plus, no water-based aspirators allowed things like vacuum generators that just run water constantly. You asked earlier, how much do these process changes save? The answer is a huge amount, both directly in water volume and indirectly by cutting the energy needed for pumping and treating that water. It's a real win-win.
Wow, okay. They really have thought about water use from like the faucet all the way to the cooling tower on the roof.
Yeah.
But what about outside the building? Landscaping can drink up a ton of water, right? Especially in drier places. How does LD handle that?
Good point. Yes, outdoor water use is the third major pillar. And again, projects have two main options here, both focused on cutting down or eliminating the need for potable water for irrigation. The first and simplest option is just no irrigation.
Just don't water the plants.
Essentially, yes. But more accurately, it means designing a landscape that doesn't need permanent irrigation after it gets established, usually within the first 2 years. You need to demonstrate it's self-sufficient.
And I guess the key to that is picking the right plants from the very beginning. Plants that are suited to the local climate.
Exactly. That's the smart way to do it. You use native plants, drought-tolerant species, plants that are naturally adapted to the local rainfall, the soil. They just thrive without needing constant watering once they're established.
Makes sense. Less work, less water.
Right. It leads to more resilient landscapes, too. But, okay, what if some irrigation is necessary, maybe for a specific type of landscape design or climate? Then the second option is efficient irrigation. If you are going to irrigate, you have to prove you're reducing the irrigation water demand by at least 30% compared to a calculated baseline.
30% reduction. How do projects achieve that? Just better sprinklers.
Better technology is part of it, yeah.
Mm.
Using things like drip irrigation, which delivers water right to the roots, or microsprays. Minimizing evaporation and runoff is key. But it's also about smart design again. Appropriate plant selection still plays a big role, even if you irrigate. Maybe grouping plants with similar water needs together. And the calculations often use a standard method, like the EPA's TIR theoretical irrigation requirement, to make sure everyone's measuring savings the same way. And thinking bigger picture, this isn't just saving water today, it's about creating landscapes that are healthier, more resilient, maybe support local biodiversity better, and need less maintenance overall.
So, okay, we've covered inside, outside, fixtures, equipment. These are the standards. But how does this actually happen on a project? For you, the listener, if you're maybe an architect, engineer, or builder, or just curious, how does a team actually implement all this? Sounds like it needs a lot of planning and, well, making sure everyone's on the same page.
It definitely does. Implementation has to start early, like right at the beginning of the design phase. It's not something you can easily bolt on later. You need close coordination between the architects, the plumbing engineers, the landscape designers. Everyone involved needs to understand these requirements from day one.
So communication is key.
Absolutely. And another vital piece is integrating metering and submetering. You need to measure the water use to actually prove you're meeting the targets. In fact, there's a whole separate prerequisite, WEp1, just focused on water metering. It underpins this efficiency prerequisite. You can't manage what you don't measure.
Right, so you can't just say you installed efficient toilets. You need the data to back it up.
Mm-hmm.
That adds a whole layer of needing to prove performance.
Precisely. Data is fundamental for verification in LEED. And project teams rely heavily on established standards and guides, things like the WaterSense specifications, Energy Star product lists, ASHRAE Standard 189.1. These provide the technical details. And for those more complex projects, especially using the performance path, teams often use energy or water modeling software.
To simulate it beforehand.
Exactly. To simulate the building's expected water use based on the design choices. It helps prove the savings before anything is even built, lets you tweak the design for better results, and catches potential problems early. Very useful tools.
This has been a really great walk through the nitty-gritty details. Really
Right.
fascinating how much thought goes into just the water aspect of a green building.
Right.
But maybe let's zoom out one last time. Why does hitting this specific prerequisite, WEp2, actually matter? Beyond getting the points for LEED certification, what's the bigger impact that you, listening, should really take away from this?
Well, meeting this minimum water efficiency prerequisite, it's a really significant practical step towards conserving fresh water. And we know those resources are under increasing pressure everywhere. Climate change, growing populations, water stress is a major global issue. And as we touched on, it also directly cuts greenhouse gas emissions. Less water needing treatment, heating, and pumping means less energy used, which means a lower carbon footprint for the building's operation.
Right, the energy connection again.
Yeah. And then for the people who own and operate the building, there's a very direct benefit. Lower utility bills, reduced water, and often energy costs over the entire life of the building. That adds up. So really, it's not just about checking a box for LEED. It's genuinely about building smarter. It's about creating buildings that are more financially viable, much more environmentally responsible, and ultimately more resilient for whatever the future holds. It connects everything from that tiny faucet aerator to the big cooling tower to these much larger goals.
It really does frame it differently, doesn't it? Thinking about buildings not just as structures, but as like responsible citizens, contributing positively to the environment and resource management. It's a powerful idea. Our deep dive today into LEED V5's minimum water efficiency prerequisite really highlights how these thoughtful, sometimes detailed design choices can ripple outwards, creating huge impacts. It connects your everyday kitchen faucet to, well, global climate goals. Makes you wonder what other, maybe seemingly small, changes in how we design and build could unlock similarly massive benefits for sustainability. Something to think about. If you enjoyed this deep dive and want to keep exploring the world of sustainable building, green design, and all the cutting-edge insights shaping our future, definitely hit that subscribe button. You'll hear more about this world and how we're innovating towards a better built environment. Thanks for joining us.